Okay, I want to start out this section 4.1 homework video by taking a look at some graphs and determining whether or not they're a function, finding its domain, and finding its range. So the first one that we see here, and I think that you can tell that I've done a little bit of coloring, we have to remember that the domain is from left to right and the range is from up and down. And so when we first look at this, we're going to look at the domain. Well, you can see that I've colored that in green, and you can see that it goes from 0 all the way over here to 5. However, notice at 5 there's an open circle, and at 0 there's an open circle. So the domain of this particular picture is from 0 to 5 with parentheses. Now, as far as the range goes, we're looking to see how far up and down, just the y values. You can see that it goes from -1, that this point is at -1, and it goes all the way up to the number 4. But again, at -1, there's an open circle, and at 4, there's an open circle. So the range is going to be from -1 to 4, again, with parentheses. Now, the next question is this a function? We want to use the vertical line test. Regardless of where I draw a vertical line, the answer to this is yes, it is a function. The line only goes, one of the vertical lines only go through the picture once. Okay, second one, same thing. We're going to look and see the domain, the range, and if this is a function. So again, as far as our domain goes, we're looking from left to right. And you can see in the green that the furthest leftmost point is a -2. And since there's a closed dot, I'm going to have -2 with a bracket. And the furthest rightmost x value point is the number 4. But since there's an open circle at 4, I'm going to put 4 with a parenthesis. Now again, for the range, I'm looking to see how far up and down this thing goes. Well, you can see that this black point, the y value is a -3, and since it's closed, I will go -3 with a bracket. And how far up does this point go? Or excuse me, does this line go? Up to the +3, and since there's a line actually going through this, that would be considered a closed dot. However, over here, there is an open dot at 3, and so we will have to put in there a parenthesis. Okay, lastly, is this a function? Well, regardless of how many times I draw my vertical line through this, the answer is yes, it's a function. Okay, next one. When I look at this, I want to see how far left and right this goes for the domain. So it goes all the way to -5 with a closed dot, so -5 with a bracket, and it goes all the way right to the number 4 with a closed dot, so 4 bracket. As far as the range goes, again, I want to see how far up and down this thing goes. And so the lowest y value that I see is a -4 with a closed dot, which is a bracket. And how far up this thing goes is a +5. And since it's a closed dot, it is also with a bracket. Now the question is this a function? Well, if I draw my line here or here, the answer is yes. However, if I draw my line over in this direction, hey, look, it passes through the line twice. It only has to happen one time. It only has to pass through it one time for it to be considered not a function. So the answer for this one is no, it is not a function. All right, next one, same thing, my domain. How far left does this thing go with the x's? It goes all the way to -5, but with an open circle, so -5 with a parenthesis. And then how far to the right does it go? All the way to +5, this time with a closed dot, so (5) with a bracket. As far as the range goes, I want to know how far up and down are the y values. And so this dot, the lowest it goes is -3 with an open circle. And how far up does it go? This is a +2 with a bracket. And again, is this thing a function? If I draw any vertical lines, does it hit the thing twice? The answer is yes, it's a function because it passes the vertical line test, and now I am finished. Okay, next I want to look at several different graphs, and I want to be able to just look at it and tell whether or not it's a function. And so I have several of them here. And so the first one that I'm going to look at is this guy. And I'm going to pick a point and I'm going to draw my vertical line. Oh, look, it passes. It continues to pass the vertical line test. So this guy, yes, he is a function. Done. This next one, it just takes one line to prove to me that no, this is not a function. Okay, it goes through the line more than once. The third one, this is just a linear function. It's a straight line. So anywhere I put a vertical line, it's only going to hit it once. So the answer, yes, this guy is a function. This one, he's not really what we would call a line, more of maybe like a little bit of a shape. But regardless, if we draw a vertical line through any of the x values, it only hits once. So yes, this is a function. And the last one, this is a circle, and when we draw a vertical line through it, we can see right off the bat that it touches more than once, and so we know that no, this is not a function. Okay, the next thing that we are going to do is take some equations and rewrite them as functions by solving for y, replacing y with f of x. So the first one, I'm going to have x minus 6y over 2, and that will equal -2. And my goal, when it's all said and done, is to say this is f of x equals something, because I want it in function notation. And so the first thing that I'm going to have to do here is solve this equation to get y all by itself. And so I will do that by multiplying both sides by 2. That will give me x minus 6y equals negative 4. And then I will subtract x from both sides. And I will get negative 6y equals negative x minus 4. And then I will divide both sides by negative 6. And so that will give me y equals 1/6 x plus, so 4 over 6. And I'm going to take this y value out, and I'm going to replace it with f of x. And then I just rewrite the equation. Over here, I know that this is a fraction. I want to simplify it. If I divide both sides by 2, it'll give me 2/3. And so I will say that my function is actually f of x equals 1/6 x plus 2/3. So this is the first part of my answer. Now, once I have this written in function notation, I want to find f of 1. And so what f of 1 means, instead of the x being here, there's a 1. And so up here in this equation, anywhere I see an x, I'm going to replace it with a 1, and I'm going to evaluate that. And so I will rewrite this as f of 1 equals 1/6. Instead of rewriting x, I'm going to put a parenthesis and put a 1, and then plus 2/3. Well, 1/6 times 1 is just 1/6. And if you want to use your calculator to add 1/6 and 2/3, that's totally fine. When I do that, because I already did it, it gives me 5/6. Now, from what I know about this is my x value. I replaced it with the number 1. I stuck the number 1 into my function. I did some calculations, and it popped back 5 over 6. This is actually a point, 1,5/6. Somewhere out there on the line, this point is on this particular function. Now, the next part, so that's the second part that you'll see in Hawks. The third part says, hey, go back to the original problem before you did anything to it and find its domain. And so if we do that, here's my original problem. Let me rewrite it for you because this is messy. It's x minus 6y over 2 was equal to negative 2. And I need to know the domain of this. Well, I don't want to have to graph this because I don't know what it looks like. I want to do it algebraically. So I look at my problem and I say, okay, I have 2 rules. First rule, are there any variables in the bottom of this? The answer is no. Second rule, are there any square roots anywhere in this? The answer is no. And so that tells me that I have no domain restrictions. And because of that, my domain is actually all real numbers. Done. Let's try another problem that's similar to that. So what if I had 5x squared plus y, and that was equal to 3x plus 3y. And I need to rewrite this, as a function. So as a function f of x. Well, again, what I need to do is get this y all by itself. Well, get these y's together and get the y all by itself, and then replace the y with f of x. So the first thing I'm going to do is subtract y from both sides. Gives me 5x squared equals 3x plus 2y. And then I will subtract 3x from both sides. Now be careful because this is 5x squared and this is just 3x. They're not actually going to subtract here. So I'm going to have 5x squared minus 3x is equal to 2y. Now I'm going to divide both sides by 2. That will leave me with y equals 5x squared minus 3x over 2. And again, I want to get rid of this y, replace it with f of x so that I actually have a function and no longer just an equation. And so it's really easy. I just literally pick up the y, take it away, replace it with f of x. And this is the first answer. That's my actual function. Now, the second thing that I'm going to want to do once I have this is I want to find f of, let's say, 2. And so again, anywhere I see a x in my function, I'm going to replace it with the number 2. And so that will give me 5 times 2 squared minus 3 times 2 all over 2. And now this is just an order of operation problem. So I'm going to come to the top and say, okay, well, 2 squared is 4, and 4 times 5 is 20. Subtraction sign. 3 times 2 is just 6. This is still over 2. I need to do the top first. So 20 minus 6 is going to give me 14. That's still going to be divided by 2. And when I do that, my answer is going to be 7. And so what I'm doing here, what I'm really getting is I stuck the number 2 in for x. I did some evaluations. I got 7 that's popped back out at me. So x is 2 and 7 is y. And again, y. Oh goodness, y. This is a point, 2, 7. And then again, lastly, on this problem, I need to find the domain. And it's going to say, hey, go back to your original problem, which was way up here. And it's going to say, what's the domain of this? And so I'm looking at my original problem and I'm saying, okay, is there a fraction with an x in the bottom? No. Is there a square root symbol? Also no. And so what that tells me is there are no restrictions on my domain. And since I know that there are no restrictions, my answer to my domain is all real numbers. Done. Okay, so the next thing that we want to look at is, let's say that we have g of x equals x squared plus 3. So we've already got a function. And we've already been plugging things in, but now instead of plugging in a number, we're going to plug in a quantity. So let's say I need us to find g of x squared. Well, the same thing that just happened is going to happen. I'm going to take this is my new x, and anywhere I see an x, I'm going to plug that in. And so what I'm going to write down is I'm going to write g of x squared equals, now notice this x is what's going away. This little square is still here. So I'm going to have x squared. This guy is still there, so he's being squared again, and then plus 3. Well, we've learned way back that when we are taking a power and we are raising it to another power, this becomes x to the 4th. This is just a nice, neat, regular 3. Nothing's going on. And so my answer would be g of x squared equals x to the 4th plus 3. Totally done. Now, what if, let's take a look at a different one. So maybe we have g of x, and we've already been given this function, which is, I don't know, negative 4x plus 1, let's say. And again, we want to find g of x squared. And so in this particular problem, anywhere I see this x, I'm replacing it with this x squared. And so what I'll do is I'll write g of x squared equals negative 4, and its parentheses is the x squared plus 1. And so this is going to be super easy. If I have negative 4 and I multiply it by x squared, that's just negative 4x squared. No big deal. And so my answer here is going to be g of x squared equals negative 4x squared plus 1. Totally and completely done. Now, let's take a look at what happens if I put more than just a variable in there, because that will come up. So let's say that g of x is equal to x squared minus 3, and I need you to find g of x minus 1. Okay, well, all this means is anywhere in my problem that I see an x, I'm going to replace it with the quantity x minus 1. And so I will write g of x minus 1 equals, this x is now x minus 1. This little square is still totally there, and the minus 3 is also there. The only thing that I've done is I've taken this x and I've replaced it with the quantity x minus 1. And now I have to, simplify this. Well, we've learned way back that when we have a quantity and it's being squared, I have to FOIL. This minus 3 just hangs out. And so here I go. So that'll give me x squared minus x plus 1. This negative 3 is still there. And so now I'm going to combine my like terms if I can. So I will have x squared. These two guys will come together and give me negative 2x. These two guys will come together and give me negative 2. Now I don't have anything else I can combine, so I have to stop. So I'm going to say my final answer is that g of x minus 1 equals x squared minus 2x minus 2. And this is it. Done. All right, so the last thing I want to look at in this homework video is how to find, they call it the implied domain. I just say the domain. How to find this domain using algebra rather than graphing. Because sometimes, for example, maybe we have f of x equals 7 over x minus 15. Well, I sure don't know what that looks like, and I don't want to spend a lot of time graphing it. So what I'm going to do is I'm going to remember my rules. One rule is that I can't have 0 on the bottom, right, on the bottom here. And the second rule is if I have a square root symbol, it has to be greater than or equal to 0. These are my rules. And so I look at this problem and I say, hey, look, in the bottom, there's a variable. So right off the bat, I know that x minus 15 cannot equal 0 because I know that the bottom cannot be 0 because I'm never allowed to divide by 0. Well, all I have to do is get x by itself to figure out what x can't be. So I'm going to add 15 to both sides, and I will get that x cannot equal 15. All right, so then what that means is somewhere out here on this number line, here's the number 15, let's say. The only number that is not allowed to be part of my solution is the number 15. So all of these numbers can be, I can't have 15, and then all of these numbers can be. And so in order for me to write this in interval notation, I'm going to say, well, this is going from negative infinity all the way to 15. I know that I can't include 15, so I have to use a parenthesis. Well, that's only this piece. I still have this piece to go. Here's my union symbol. Well, I'm starting again at 15, and how far am I going? All the way to infinity. And so this whole entire thing right here is my domain. It is saying all the numbers except 15. and that's the only number I said I had to exclude. And by doing this, by skipping 15 and including my union symbol, I've done just that. So I'm completely done with that one. Now, what if, number 2, what if I have f of x equals, let's say, the square root of x minus 8 on top, and that's being divided by a negative 14. Okay, well, I look at the rules and I say, is there a variable on the bottom? No. Is there a square root symbol? Yes. And so what that tells me is that the square root of x minus 8 has to be greater than or equal to 0, because I can take the square root of 0, I can take the square root of a number that is positive. And so what does that mean? Well, that means that x minus 8 has to be greater than or equal to 0. Well, I'm going to add 8 to both sides and get that x must be greater than or equal to 8. Well, again, if I look at my number line, let's say this is 8. How do I represent x is greater than or equal to 8? At the number 8, I'll put a bracket. It will be opening towards the right, and then I will shade this way forever. And so if I'm going to write this in interval notation, where do I start? Well, I start with 8 with a bracket, and how far do I go? I go to infinity. And of course, when I use infinity, no matter what type of math I'm doing, I always have to use a parenthesis. And so the domain of this guy is 8 with a bracket all the way to infinity with a parenthesis. And now I'm done. Now, number 3 is going to look very similar to the one that we just did. However, there's one teeny tiny difference. So let's say that f of x is the square root of x plus 3, and on the outside I have a minus 7. Well, I look at my rules. Is there a variable in a bottom fraction? No. Is there a square root symbol? Yes. For the time being, I don't care about this guy. I only care about this piece. Okay, and so what that means is, well, the square root of x plus 3 has to be greater than or equal to 0. And so I know that x plus 3 itself has to be greater than or equal to 0. And so I will subtract 3, and I will get that x has to be greater than or equal to negative 3. And so here I go with my number line again, and eventually you may not need one of these. So here's negative 3. How do I represent x is greater than or equal to negative 3? Well, I draw my bracket facing towards the right, and again, I will shade this way forever. And so if I want my answer in interval notation, I say, well, how far to the left do I go? That's negative 3 with a bracket. And how far to the right do I go? That's infinity, positive infinity. And again, I know that if I'm using positive infinity, any infinity, it's always a parenthesis. And so here's my final answer. Okay, number 4. What if I have something that looks like this? G of x equals 5x squared plus 2x minus 7, let's say. And so again, I'm trying to find the domain. And I want to find the domain algebraically. I don't have to graph this. Well, I remember my 2 rules. I say, okay, is there a fraction which contains a variable on the bottom? No. Is there a square root symbol at all? No. And so because of that, this is in this particular case, there are no domain restrictions. And so when there are no restrictions, what that means is, as far as my number line goes, this baby's wide open. It means every single number, no restrictions. I don't have to stop for anything. So it's everything. And I can represent this 2 ways. One of 2 ways. I could say it's from negative infinity to positive infinity, or you can just draw the all real sign. I do this a lot. And now we are completely and totally done.